Hey there, awesome folks. Onkar here. In this video, I got you something super cool. A important feature about Maxwell I have recently uh, discovered, and trust me, you are going to love this feature. This feature helps you to record a script. So the activities you are doing in this Maxwell environment, you can record it as a script. You can save it as a script, and then you can reuse that script to recreate that whole model, or you can tweak the script here and there to get the desired output, desired task done. So one of the important application of this function is to recreate and modify the geometry. Those who are working on electric machine would be knowing that whole day you are doing the reiterative work. You are tweaking with the machine's geometry. You are increasing its outer dia. You might be changing its inner diameter. You are playing with its slots, and that could be a very tedious task. And maybe you are not getting the precise shape what you want, or to make that the precise shape, it might be taking a lot of time to you. So this record script feature could be a great help for you guys. Uh, in this video, I'll show you how to work around with it. We'll start with a very basic example. To begin with, uh, we have to go to the this tools menu, and that there is option record script to file. Uh, let's name the file. We'll name draw underscore box. There are two languages in which you can write the script. In this video, we'll work around with IronPython and save it. Now, if you go to the tools menu, you can see script is recording. Once you done with your editing, you can once you're done with your editing on the GUI, you can stop script recording. So to begin with, we'll start with a very basic geometry. We'll create go to draw menu, and then we'll create one box. So here is our box. Done. We'll stop the recording. Okay, that's it. So now let's go to the folder where we saved the script. Here you can see the script is here, draw underscore box. Uh, I use this Microsoft Visual Code to edit the script, but you can use Notepad also. Once you open it, you can see it here. But I'll show you in a Microsoft Visual Code. So here it is. So this I use it because it gives a very nice uh, view of the script where I can see what are the functions. It's the different colors for the different functions and for the parameters. So it's easy to identify some mistake, and it's nice to edit in this platform. So these are the some of the initial configurations which you have to do when you start scripting. Uh, with this, you will run the Ansys electronic desktop. Then in this variable O project, what you are doing is you are setting your active project as a PS487. If let me go to the our project, here you can say our project name is PS487. So here we are defining, we are saying it as set active project as a 487, PS487, and it will be stored in this variable. And then from that project, we'll access this design, source for mesh. We'll set the active design as a source for mesh. We can see there is this only one design, source for mesh. But let's say it has a multiple designs, and you want to edit in a particular design. Here you will specify the name for the design, and then in the we have to set the model active editor. So the editor for the drawing, some of the drawing commands which you can see here in the screen. R comes under this editor. So we are setting the active editor as a 3D modeler. Now the real fun begins. Here we are creating a box. This is the function for creating a box. Note, this is the auto-generated script. I haven't done anything. This Maxwell itself has created whatever we have done in the Maxwell GUI or Maxwell IDE. The same thing. It ultimately the what Maxwell is doing. There is some codes, pre-written codes are running. What you are selecting the option to execute those commands in on the behind some script is running, right? So that same script it has recorded and give it us in this file, a nice looking file. So this is the box which runs behind the screen to create the box you want. And these are the first three parameters to create box is to set the origin. So in our design, the origin is set as minus at location -5, 1, 1 to 5, and 0, which we can verify. Let's go to major position, and this is our origin. Here you can see on the screen, on the left side of the screen. This is the left side of the screen. The position 2 is -5, 1 to 5, 0. That's it. That's the origin we have. And these next three parameters scales or sets the length in the XYZ axis for the box. And then we can name the box. For now, we have named it as a box 1. These numbers are used to set the color. And we can define here some value, a material value. Right now, it is a vacuum. Now, let's go again to the Maxwell window. I will delete this box. And now I'll go again to the tools. Now I will do the run script. I'll play the run script option. So now I'll select the file which we have created. And woohoo, our box is here, the box 1. And it is created not by hand, it's created by the script. Let's again delete and let's tweak the script here and there. We'll keep the origin at its same location, but now I want to make it as a perfect cube. So I will make all the XYZ lengths as 20. I'll save it, Control S. Then again, go again to the tools, run script, select the file, draw box, open. Ta-da! Our box, our cube, nice looking cube is ready. So let's see what more we can do. Now what I'm doing is I'm copying this function, entire function here. And what I will do, now what I want to do is I want one cuboid on top of this existing cube. Which has a length in y-axis around 40 mm. So let's mark the origin for that cube. It is -5, 1 to 5, and 20, which you can see on the left side of your window. Now let's go again. We'll change the origin. We'll keep x position -5, y position we want to keep it as the same, 1 to 5, and then z position we'll keep 20. And we want its length in y-axis around 40, double of our old cube. And don't forget to change the name of the cube. We'll give it as a name as a box 2. Again, press Ctrl S to save it. Delete the old cube. Go to the tools again. Run script. Our very old this nice script, Drawbox, open it. Ta-da! It has created now two boxes, one on top of another, and nice simple geometry it has created. And you can see we'll measure what we have created. We'll set this as our reference, and you can see the y distance on the left hand side is 40. It has created a cube with a 40 mm length in y-axis. Length in a z-axis is 20. You can see it on the left hand side, and length on a x-axis we can see it here as a 20. So with this scripting, we can create a precise shape. So let's say if you are working, you are drawing a normal tool with a normal draw tool, you might not be able to set the precise shape because you are limited with the grid, or if you have to increase the precision, you have to zoom it, and then you will probably uh, create that shape, and which might not be that precise. The precision you want might not be able to achieve, and let's say you have to do it again and again. You have to tweak it here and there. Then the normal what you use, the drawing tool, it will be a very tedious job. So this script will come to your help. All right, you fabulous people, that's a wrap for today. In future videos, I'll show you the more use cases of this important feature, which will help you in your simulation journey. Uh, on the left hand side, you can see a geometry which we haven't touched in this video. This is a transformer, high frequency transformer. In the future video, we'll work around with this geometry, we'll modify it, we'll do some changes, and some uh, more than this drawing feature, we'll see what more can this script can do. So we'll unveil the unknown potential of this powerful tool, Maxwell. Stay tuned for more mind-blowing adventures on this channel. Until then, keep exploring, keep creating, and keep scripting. Thanks a lot, guys.